Okay guys and girls, welcome back to another episode of the chemistry tutorial. Last session what we looked at was group 1 elements. Group 1 elements are of course these ones down here, so all of these are group 1 elements. Today we're going to be looking at group 7 elements. So let's get started. Group 7 elements are called halogens. Okay, so they have another name called halogens. Now what we need to know about group 7 elements is how they are in terms of their trends. If you remember, with group 1 elements down here, what we should have learned is that they become more reactive as you come down the group. Now the way to kind of remember that, a crude way of remembering that, if you know me, I'm full of crude ways of remembering silly things. If you look at this one has the symbol FR, which is francium, and if you think about it, the way to remember that it gets more reactive as you go down is the reaction between francium and water is going to be very frightening, right? So it's going to have a severe reaction, a very extremely vigorous reaction. So that's the way to remember that it's going to get more vigorous down at the bottom. So what about in group 7? So the trend you have to remember is actually the opposite of group 1, but I'm going to show you another extremely crude way of remembering this. This one is fluorine, right? This has the symbol F on its own, and to put it quite simply, a fluorine is the element that you do not want to F with. Okay, so this is the most reactive out of all of the group 7 elements. Okay, so you need to know that, and we're going to talk more about the reactions and how we kind of figure out that it is the most reactive. But the way to remember that fluorine is the most reactive in group 7, because you just do not F with it, it will mess you up quite literally. And group 1, if you look at francium, it is very frightening, so this is the one that's most reactive. So they have an opposite trend, and by the end of this tutorial you should be able to explain why. So here I've made a table that's already kind of ready made, and like I've said, we call them group 7 elements halogens, and we're just going to talk a little bit about their molecular makeup, so the molecular formula. So fluorine, when it's on its own, all of group 7 elements exist diatomically. So what that means is that there are two of itself joined together. So for example, fluorine does not exist as just F, right? It's diatomic, so there are two fluorines that are joined together. So it actually exists as F2. There are two fluorines joined together. Now if F fluorine exists as F2, I want you to pause the video and have a go at what you think, or how you think chlorine, bromine and iodine exist by themselves. Right, so pause the video, have a go at that. I'm just going to carry on right now and go with the state at room temperature. So fluorine is a gas at room temperature. Chlorine exists as, see if you've got it right, Cl2. So in other words, there are two chlorine elements joined together, and this is also a gas at room temperature. Bromine exists as Br small 2 because it's diatomic. Remember, all group 7 elements are diatomic. This exists as a liquid at room temperature, and iodine exists as I small 2. So it exists as iodine, and this exists as a solid. So one of the trends, or one of the properties as we go down, is it turns fluorine is a gas, chlorine is a gas, liquid and then solid. So just by looking at this, what we could say about group 7 elements is that the melting and boiling point, so as we go down group 7, the melting and boiling point, it increases, right? Because obviously at this point here we've got solid, and at this point here right at the beginning we've got gases, so the melting and boiling point is actually increasing as we go down the group. So that's learning point number 1. Learning point number 2 is here. when we have halogens that react to make a compound, it changes its name. If you notice here, we've got fluorine, INE, chlorine, bromine, and iodine, right? Those are when they are on their own, that's how we name them. However, once they react with something, and I've given some examples here, what we have is they change their name to IDE, and we call them halides. So on their own they are halogens. When they are reacted with something else, they are halides, right? So, and as you can see, they all end in IDE. So fluorine has gone to fluoride. Now you should be able to answer this question really, is what is the ion form of fluorine? So you got to think back to those early videos. Fluorine, let's go to the periodic table. Fluorine is in group 7, right? So fluorine is in group 7, right? So how many electrons in the outer shell? You got 7 electrons in the outer shell. We need it to become a full outer shell. So the question is, how many electrons does it need? How many electrons do we need? And the answer is 1 electron. So if fluorine ends up gaining 1 electron to make a full outer shell of 8 electrons, what charge will fluorine have? And the answer is F minus. Just get rid of that. So it's F. It's an F minus charge, right? So fluorine, once it becomes a halide, has an F minus charge, right? Because it's gained an electron, so it's going to have an F minus charge. The chemical equation for fluorine is HF. Now if you think back, we've already covered ionic bonding, and ionic bonding, if you remember, or you should remember anyway, is the bond between a metal and a non-metal. So if you look here, here is our line, and once again, can you see guys how all of this is really important to understand the basics first? So all of these are metals, and anything on the other side, all of these are non-metals. Now one other thing is hydrogen is also a non-metal. It belongs to group 1 period 1. However, the reason why it's not put here is these are metals, so it's kind of a bit odd to put this in the metal section, although you will see some periodic tables that put it there. However, it's best to leave it on its own because it's not a metal. So we looked at ionic bonding, which was the bonding between metals and non-metals. However, if we look back, hydrogen is a non-metal and fluorine is a non-metal. We're going to learn about this in more detail. However, for now, just believe me and trust me that when it's 2 or more non-metals joining together, we call this a covalent bond. So what type of bonding is this? It's a covalent bond because the 2 things that have bonded together are non-metals. Now here I've got another example of sodium and chlorine, which have combined to make sodium chloride. And if you look, sodium is here in group 1 and chlorine is in group 7. So when they combine together, they make sodium chloride. So that's a metal combining with a non-metal. That is ionic bonding. So let's get the type of bonding first. Ionic bonding. Why is it ionic bonding? Because it's the bonding between a metal, which is sodium, and the chlorine, which is a non-metal, so that's ionic bonding. So what charge should chlorine have, or the chloride ion have? Now for the chloride ion will have a negative charge. Again, the same reason why the fluoride ion has a negative charge. Chlorine is in group 7. It needs one more electron to have a full outer shell, because it needs 8 in total. If it gains 1 negative electron, you have a charge of -1. So remember, you don't have to write 1, just writing negative is fine. So here we've got sodium and chlorine, which combine together to make sodium chloride. What's the chemical formula? You should be able to do this, guys, because remember, this is ionic bonding. You've got sodium, which is Na, right? It's in group 1, so it will lose 1 electron, because remember metals lose electrons. So it's Na plus, and you're going to react that with chlorine. And when chlorine, that needs to gain an electron, so it's going to have a negative charge overall. You swap the numbers around. In this case it's 1 to 1 anyway, so the sodium will have 1, the chlorine has 1, so it's going to make NaCl. That's going to be your next chemical formula, so it's NaCl. Now have a go at this column here. So it is a bit tricky and you will need the periodic table. So if you got your planners, and people that go to my school, you've got a periodic table in your planner, do have a go. So pause it, have a go. I'm going to carry on right now. So bromide will have a Br negative charge, and it's for the same reason. I've been through it. Now magnesium and bromine, if you look at magnesium in group 2, right, so magnesium is in group 2, there it is. So it's got 2 electrons in the outer shell. It's a metal, so it's going to lose those electrons. If you lose 2 negative electrons, you're going to have a charge of 2 plus. And we're going to react it with bromine. Remember, when we're reacting it with bromine, bromine needs 1 more electron to make a full outer shell. Now here we're going to swap the numbers around. This number 1 is going to go to here. This number 2 is going to go to bromine. So I'll just draw my arrows. So the formula for this is MgBr2. And what type of bonding is it? Well, it's a metal with a non-metal, so it's ionic. So let's go MgBr2. What type of bonding? It's ionic, because of course it's between a metal and a non-metal. So if you've done this already by yourself, have a look. So when it becomes an ion, it's going to be iodide, which will have a negative charge. Hydrogen iodide, which is Hi, and you will learn more about covalent bonding later on, but just trust me for now, this is covalent bonding because it's 2 non-metals that have reacted together. Okay, well done if you have got that. If you haven't, this is something that you need to be going through and learning. So with that said, let's have a look at the reactions between fluorine, chlorine, bromine and iodine with hydrogen gas. Okay, so firstly let's go with fluorine. So fluorine, by the way guys, is extremely toxic. Okay, like literally it will F you up, right? So don't mess with fluorine. So remember, fluorine exists as diatomic, so it's F2 plus hydrogen. Now you should know that hydrogen exists as diatomic as well, so it's F2 plus H2 makes HF, right? However, this is not balanced, so to balance this we need to add, so if you look here, you've got 2 fluorines, 2 hydrogens, and you've only got 1 hydrogen and 1 fluorine. Nice and simple, you put a big 2 in front of the HF, so now you got 2 hydrogens here, 2 fluorines here, and the reactants and the products are the same, so happy days. So what I want you to do is to write out the equations for the reactions of chlorine with hydrogen, bromine with hydrogen and iodine with hydrogen. You need to be able to do this, guys. So pause the video, do that, then unpause it. So what we've got is Cl2, because remember it's diatomic, so it needs to exist as 2. We've got hydrogen, which is going to make HCl, hydrogen chloride, and then you need to put a big 2 in front of that. So chlorine, well, we've done chlorine, so now it's bromine plus hydrogen. Now remember, why is it 2? It's because it's diatomic. Plus your hydrogen, which is also diatomic, is going to make, and you will kind of realize why they are diatomic. In fact, you know what, even though you're supposed to be learning it in covalent bonding, I'm going to tell you it after I do these equations, because I think it's really important that you understand what's going on and it's not just done based on trust. Okay, so it's going to be HBr, and then you just need a 2, so it balances out. Same with iodine, really. I2, why is it I2? Come on guys, you need to be able to tell me, because it is diatomic. Hi, and just put a 2 in front of it. So nice and simple. So let's go into a bit of covalent bonding, right, and explain why it is Br2, etc, etc, etc. Now With covalent bonding, once again, it is about the electron shells, and it is about the electron shells, etc. So let me just increase the opacity and have a look at this. I'm going to take fluorine, which bottom number is 9, top number is 19. So if I go fluorine, so if I go fluorine 19 and 9, that's a 19. Let's revise, let's do our pen number, P-E-N. How many protons? Well, it's 9 protons. How many electrons? Well, it's 9 electrons. Let's do a bit more revision. Why are these the same numbers? Because you got 9 positives, 9 negatives, they cancel out, so our atom is overall neutral. So that's just a bit of revision. How many neutrons? Well, it's going to be 19 minus 9, which is 10 neutrons. So protons is 9, electrons is 9, neutrons is 9. Now we're going to look at the protons, because that's what we're interested in with covalent bonding. So all group 7 elements exist as diatomic atoms, and so because of this they are covalent. A covalent bond is simply a bond between 2 or more non-metals. So when 2 or more non-metals are joined together, right, it's called covalent bonding. Right, so let's draw fluorine. Right, so fluorine is here, and my first fluorine, and it's going to have 9 electrons. So what I've got is in fact, because all of the bonding occurs on the outermost electron in covalent bond, we can ignore every single other electron. We can ignore the inner shells, we can ignore all of that. So because of that, that's what I'm going to do. I'm going to ignore all of the inner shells and just focus on the outer shell. So this makes my job a lot easier. I know, and again this is more revision, I know that on the outer shell of fluorine there are 7 electrons, because it's in group 7. So it's 1, 2, 3, 4, 5, 6, 7. So look at this. Here's a pair, here's a pair, here's a pair, and this one is alone. Now what electrons like to be, they like to be paired up. So what we're going to do is we're going to draw another fluorine atom. So I've got a fluorine atom, and just to make sure that I can tell the difference between the two, I'm going to do this, the electrons with this one in dots. So it's going to be 1, 2, 3, 4, 5, 6, and 7. Why is there 7 electrons? Because they're in group 7, so the outermost shell will have 7 electrons. Now can you see, it's a very simple solution. We can join this lonely electron with this lonely electron, and let's do that now. So I'm going to make an arrow, so when you have these two together, you add them up, what you're going to have is you're going to have this situation where you're going to have fluorine number 1. Right, so let's draw that. 1, 2, 3, 4, 5, 6, and here's my 7th electron. Right, so I'm doing this this side because I could have done it any side, but I've just chosen the lonely electron to be on this side. Doesn't really matter what side it's on. And here's my 2nd fluorine atom. Right, so this one I'm going to represent with dots, remember, and in fact what I'll do, just to make it even more obvious, I'll change the color. So I've got 1, 2, 3, 4, 5, 6, 7, and oh look at that, it's got an 8th one now. So this fluorine has in total 2, 4, 6, 8 electrons, which is a full outer shell, which is brilliant because it's more stable now. And this fluorine molecule has 1, 2, 3, 2, 4, 6, 8 electrons as well. So they both have 8 electrons, which means that they have a full outer shell, so it's more stable. But can you see now why, through covalent bonding and the sharing of electrons, from being lonely, right, from having a single electron to joining them up, you have a more stable structure and you have a diatomic molecule. So you can do the same for all of this. for all of these, from hydrogen, bromine, chlorine and iodine, it all works the same. Let's have a look at hydrogen and chlorine. Let's take hydrogen and chlorine. Now hydrogen has 1 and 1. That's the composition of hydrogen. So let's take chlorine, which has 17, right? Now chlorine has 17 electrons and 17 protons. Now like I said, because it is covalent bonding, we are just interested in the outermost electron. So hydrogen is like this. Hydrogen has 1 electron in its outermost shell. I'm going to represent those with crosses. And chlorine has 7 because it's in group 7. So let me draw chlorine. I'm going to represent these with dots, okay, so we can distinguish between the electron. So 1, 2, 3, 4, 5, 6 and 7. So can you see a simple solution? Number 1, these are 2 non-metals, right? So as soon as you see that they're 2 non-metals, this is therefore covalent bonding. Now, as you may have noticed, what you need to know about covalent bonding is that they share electrons. Electrons are shared, and it involves the outermost electrons. And that is really covalent bonding summed up. So let's now react these two together and let's see our end product. So what we're going to have is we're going to have chlorine, right? So it's 1, 2, 3, 4, 5, 6 and 7, and the 8th electron is going to come from the hydrogen. So the hydrogen is going to have a cross here. So can you see now the hydrogen has 2 electrons and it only has 1 shell, the hydrogen anyway, so hydrogen has a full outer shell because now it's got 2 electrons, and chlorine has 8 electrons in its outer shell now. 2, 4, 6, 8, and hydrogen has 2 electrons, which makes its outer shell full, because remember, hydrogen only has 1 shell anyway, and in the first shell you can only have a maximum of 2 electrons. So that is covalent bonding done. Now there is another point which we need to go through, and that is displacement reactions. However, I think this video is quite long and I'm going to stop there, and we'll do the displacement reaction of halogens in the next video. If you do have any questions, ask in the comment section below. Thank you for those who are giving the videos thumbs up and are kind of taking part with messaging and whatnot.